All right, here is the review for test 6.2, and we're going to begin with graphing some polar coordinates. And the way we're going to do this is we're going to find the angle first, and then we're going to mark the number of units, and then we're going to label which point we have. So for number 1a, we're going to find pi over 2, which is right here. And then we're going to count 4 units from the center. 1, 2, 3, 4. And that is where we're going to put our point. So 1, 2, 3. And we're going to label this point A. Then we're going to go to 45 degrees. So 45 degrees is the same as pi over 4. So I'm going to go to pi over 4, and I'm going to count out 1 unit. That would be approximately right here. That's B. C is at 3 pi over 4 and out 2. 1, 2. D is at 0 and 210, so 0 is right in the center. This is going to be D. And then E is at 5 pi over 3. 5 pi over 3 is in quadrant 4, and we're going to go out 3 units. 1, 2, 3. And that's all you have to do for graphing polar coordinates. All right, for this next section, we're going to convert the following rectangular coordinates to polar, and I'm going to expand this picture so that we have a little bit more room to write. All right, so for the first point, we have the point 3, negative 3, which puts us in quadrant 4. And it's real important to know what quadrant you're in, because that's going to determine which angle we're going to use when we find our angle. So the first thing we're going to do is we're going to use tangent of theta equals y over x. So I'm going to put negative 3 over 3. Or tangent of theta equals negative 1. So I look at my unit circle and I see, where does tangent of theta equal negative 1? Well, that's going to be at either 3 pi over 4 or 7 pi over 4. Now, since my point is in quadrant 4, of course I'm going to select the angle that's in quadrant 4, which is 7 pi over 4. Now the radius is going to be determined by the Pythagorean theorem. R squared equals x squared plus y squared, and then we take the square root to find r. So r equals the square root of 18. So our polar coordinate is going to be square root of 18, comma, 7 pi over 4. You can also simplify the square root of 18 to be 3 root 2, but we'll just go ahead and leave it as square root of 18. All right, for the next problem, we're going to do those same steps again. I'm going to do tangent of theta equals 1 over root 3, and this is negative. And so I have to rationalize my denominator. So I make this negative root 3 over 3. And then I look at my unit circle again to see where tangent is negative root 3 over 3. Well, this happens at either 5 pi over 6 or 11 pi over 6. So I want to look to see, well, where's this point located? Well, if I've gone negative on the x and positive on the y, that puts me in quadrant 2. So I want to pick the angle that's in quadrant 2, and that would be 5 pi over 6. So that's going to be the angle for my coordinate. Now I'm going to find my r value by using the Pythagorean theorem. All right, so negative root 3 squared plus 1 squared gives me 4, and the square root of 4 is 2. And I'm only interested in the positive value since I'm only interested in positive direction. So my final coordinate is going to be 2 comma 5 pi over 6. And that is my final polar coordinate. All right, in the next set of questions, we're going to convert the following polar coordinates to rectangular coordinates. So again, I'm going to expand this so we work at these one at a time. The two formulas I'm going to use are going to be x equals r cosine theta and y equals r sine theta in order to find my x and y values. Okay, so x equals 2 cosine pi and y equals 2 sine pi. So at pi, the value for cosine and sine are negative 1 comma 0. So those are the values that I'm going to multiply times my r value 2. So 2 times a negative 1 is negative 2, and 2 times 0 is 0. So my rectangular coordinate is negative 2, 0. Now let's try B. Okay, so an explanation of what I've done here. Okay, I have my x equals r cosine theta and my y equals r sine theta. So I'm looking for x and y. At pi over 6, cosine of pi over 6 and sine pi over 6 are root 3 over 2 and 1/2. So these are the values that I'm going to be multiplying times my r, which is square root of 3. Therefore, x equals root 3 times root 3 over 2 for x, and y equals root 3 times 1/2 for y. So my result is that my x value is 3 because root 3 times root 3 is 3 over 2, and y is going to be root 3 over 2. So 3 over 2, root 3 over 2 are my rectangular coordinates. All right, for the next problem, we're doing a parametric problem. This one actually has to be graphed in the calculator, and we're going to trace the graph on our calculator as we do this problem. So the first thing we need to do, though, is write a set of parametric equations that we will enter into our calculator and then trace the graph. All right, so the two parametric equations are going to be x equals 133 cosine of 36 degrees t, and the y equation is going to be negative 16t squared plus 133 sine of 36 degrees t. Those are going to be the two equations we're going to put into our calculator under parametric equations and graphing. Now, to answer questions 5 and 6, determine how long the golf ball was in the air and determine when the golf ball reached its maximum height. Those two questions can be answered by tracing the graph. All right, so after I entered the equations into graphing parametric, I entered my x equation, I entered my y equation, and then I went to the menu and I hit Windows Zoom so that I could see the entire parabola. And I did a zoom fit, which is the last one on the zoom menu. And then I traced by going to menu, trace, graph, trace, and I traced the graph all the way around the parabola to the end. And at the end, the time was 4.9 seconds. And then I traced back to the top of the parabola to get the height, the maximum height. The maximum height, the time when the golf ball was at its maximum height was 2.4 seconds, and the maximum height was 95.5. So I'm going to go ahead and write that one in, 95.5 feet. Okay, so make sure that when you're answering your questions, you know what measurement it is you're looking at. Time is in seconds, height was in feet. Okay, for the next problem, we're going to fill in the table and graph the polar equation, r equals 2 plus 2 sine of alpha. And so since we know that this 2 plus 2 is going to give us a heart shape, so we know right away that we should be getting a heart shape when we graph this graph. So the first thing I'm going to do is find all of my r values. All right, so the first thing I did was I went ahead and I wrote in all of my sine values for these particular angles that I've been given. Since we're looking for the sine values at that angle, then I went around this unit circle and I found all the sine values for these different points on the unit circle. And these are the values that I'm going to use to multiply times 2 before I add 2. Okay, so I've completed my table, and I multiplied 2 times 0 is 0, 2 plus 2 is 2, not 0. Let me fix that. So this first one right here should be a 2. There we go. Now the next one was 2 times 1/2 is 1, 1 plus 2 is 3. The next one ended up being 3.7. The next one is 2 times 1 is 2 plus 2 is 4. And then the 11 alpha, or I'm sorry, 11 pi over 6 angle was negative 1/2 times 2, which is negative 1. And 2 minus 1 is 1. So I'm going to go ahead and graph those points. And what I should end up with is a heart shape. Okay, so I have graphed all of my points. 0, 2 here, pi over 6, 3, pi over 3, 3.7, pi over 2, 4, and then 11 pi over 6 is right here, and that is at 1. And so if you continue these points, and since they're symmetrical, they'd be the same distance on this side, they come back around, and it forms this heart shape. All right, I'm not going to spend a lot of time with this matching problem. I'm just going to go over these very quickly with you. The circle is D. That's this graph right here. This one is the circle. The limison inner loop is the one that has the inner loop. That's F. The limison cardioid is the one that's heart-shaped. That's this one right here. It has the loop, but then it comes in and makes like a heart shape right here at the center. That's C. The limison indented loop looks almost like a heart, except it doesn't come all the way into the center. That one is E. The rose, of course, is the flower, the one with the petals. That's A. The spiral of Archimedes is exactly what that sounds like. It's a spiral. And the lemniscale, that one is the ribbon, and that's B. And that's it. You just have to match the graph's name with the graph. All right, so for the bonus question, you're going to be asked to write an equation given the graph. And so this is the graph of a rose, or yes, it's just a graph rose. It has 3 petals, and the petals are 4 units long. So the way we write the equation for a rose is R equals, and then we write the number for how long the petals are going to be. Well, they're 4 units. And since this rose lands on, or is this first petal right here is symmetric about this axis, then this is a cosine. So this rose is a cosine, and it has 3 petals, so we put the number 3 right here. And then, of course, we need a theta. And that's it. That's our equation for this rose. And if you wanted to check it, you could also graph it on your graphing calculator to check that you made sure that you got the right graph with the right equation. You can always check it by graphing. And that's the end of the review. Good luck on your test, and I hope everybody gets hundreds and fives.